بسم الله الرحمن الرحيم. الحمد لله رب العالمين، والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. We are in section 5.5, and section 5.5 is about the substitution rule. It's a new method to find the integral of a function. Let us first start by the definition of differentials, what we mean by differentials. Well, if we have u equals f of x, then we can take the differential of both sides and write du. So du is the differential of u. It would be equal to the derivative of f prime x, times the differential of x. So if u equals f of x, du equals f prime x dx. We will need this in the substitution method. Now notice that integral of f prime of g of x times g prime of x dx. So g prime of x is the derivative of this function, which is inside f prime. The integral would be capital F of g of x plus c. How to check that this rule is correct? Well, find the derivative of the right-hand side. Using chain rule, the derivative of this would be the derivative of the outer function, f capital prime of g of x, times the derivative of the inside function, so times g prime of x. And this is exactly what we have here inside the integral. So this is correct. As an example, if we need to find the integral of cosine of x squared times 2x, I would like to write 2x outside here, dx. So according to this formula, I have f prime, which is cosine, g of x is x squared, g prime of x is 2x. So what would be the integral? It would be the antiderivative of cosine at g of x. So what is the antiderivative of cosine? Sine, because the derivative of sine is cosine. So the answer is sine x squared plus c. So that's the answer, because the derivative of this would be sine x squared, derivative of sine is cosine, it would be cosine x squared times the derivative of x squared, which is 2x. So what is the substitution rule? It is what we have here. If we have f integral f of gx and the derivative of gx is inside the integral, then we can take u equals to g of x. So we call this u. That's the substitution. And if you call this u, now find the derivative of both sides. So the differential of u would be equal to the derivative of g times the differential of x. So if you call g of x u, this would be du. And I can write this integral as integral f of u du. So this method helps me to write the difficult integral in an easy way and then to evaluate the integral. Look to this example. So try to find where is f, okay? Usually I need to take g of x u. So where is g of x here? Look carefully to the integral. It should be inside a function. g of x f of g of x. It's inside a function. So we have cosine x to the power 4 plus 2. So if we take u equals to x4 to the power 4 plus 2, this is inside cosine. All right. Now find the derivative. So du would be, the differential of u would be the derivative of this function, which is 4x to the power 3, and the derivative of 2 is 0 times dx. Now let us concentrate here in this integral. I have integral x cubed, but I need 4x cubed. Okay, I can write it like this. Let me write cosine first. I have cosine x to the power 4 plus 2 times x cubed dx. Now I called this u. Okay, I need du. Du is 4x cubed dx, but I have x cubed only. I need 4 here. So I will multiply by 4. But if I multiply by 4, I have to divide by 4 outside. So 1 over 4 times 4 would be 1. Nothing changed. So if I do it like this, then 4x cubed dx would be du. And now I can write this integral as 1 over 4 integral cosine u du. So this difficult integral, using substitution, using this substitution, I changed it to an easy integral, which I can evaluate. So what is the integral of cosine? It is sine. That's it. And now you can go back and replace u by x to the power 4 plus 2. So this is the integral of this function. And you can check your answer by finding the derivative of this. Another example. Search for a function which is inside something. I don't have a formula for this. If it is a square root of x, I can solve it. Okay? So 2x plus 1 is inside the root. So I will let u equals to 2x plus 1. This is my substitution. So what would be du? The derivative of this, which is 2 times dx. Okay, let us look to this integral. I have square root of 2x plus 1, and this one I am going to call it u. And I have dx here, but dx is not du. 2dx is du. So I need 2 here to call it du. No problem. You can multiply here by 2, but multiply outside by half. So half times 2 would be 1, and we did not change anything. So now I can continue. I say this is equal to half integral square root of u du. And this is an easy integral in which I can evaluate by writing square root of u as u to the power half. The integral would be u to the power half plus 1, which is 3 over 2, over 3 over 2, or times 2 over 3, plus c. So 2 cancels with 2, and we will have 1 over 3 And now I can replace u by x. I go back to x because the question originally was in x. So I replace u by 2x plus 1 and I put the power plus c. So this is the integral of square root of 2x plus 1. Another example. Do you see something inside something? G of x is inside f usually. So I will take u 1 minus 4x squared. I need the derivative of this function to be outside. Let me find du. The derivative of 1 is 0, so I have negative 2 times 4, 8x dx. Let us look to this integral. Well, square root of 1 minus 4x squared would be square root of u. And I have x dx. I can write dx here or here. But I do not need x dx. I need negative 8x dx. So I will multiply by negative 8 and divide outside by negative 8. So negative 1 over 8 integral. This one, the numerator is du, and the denominator is square root of u. I can write this as negative 1 over 8. This would be u to the power half. You take it up, so it would be u to the power negative half du. The integral of u to the power negative half is u to the power negative half plus 1, which is half over half or times 2 plus c. So negative 1 over 8 times 2 would be negative 1 over 4. And now I replace u with its value, which is 1 minus 4x squared to the power half. I can write it square root if I like. So this is the integral of this function. One more example. I know the integral of e to the power x, but e to the power 5x I don't have. So why don't we take u to be 5x, the power of e? So du would be the derivative of 5x is 5 dx. Now let us go back to the integral. E5x, 5x will be called u. But dx is not enough. I need 5 dx. I can do that if I divide outside by 5. So I can write it 1 over 5 integral e to the power u, and 5 dx is du, and this is an easy integral, and the integral of eu is eu plus c. So the answer would be e to the power, go back to x, replace u by 5x plus c. So this is the solution. Another example, you remember integral of tan x is not there because we don't know an antiderivative of tan x. Well, I can solve this integral if I write tan x as sine x over cosine x. And I can solve this integral now by substitution because the derivative of cosine is negative sine. I'll take u here to be the denominator, which is cosine x. Now what would be du? The derivative of cosine is negative sine x dx. Well, I have sine x dx, but I need a negative sign. So I can multiply by negative sign outside. So this would be negative sine x dx is du over cosine x. Cosine x would be u. Okay, so it would be integral du over u, or if you want, you can write it 1 over u du. The integral is ln absolute value of u plus c, and now you can go back and write the value of u, which is cosine x plus c. So the integral of tan is negative ln cosine x plus c. You can take this negative up here. And this is the reciprocal of cosine. And the reciprocal of cosine, 1 over cosine, is just secant. So we can say that integral tan x dx is ln absolute value of secant x plus c. Now, what would happen if we have a definite integral? What to do? Well, you do the same, but you change the limits ab to g of a and g of b. If the substitution is u equals g of x, then if x is a, because a and b are values of x, so if x equals a, you would like to know u would be equal to what? So u, because this integral in terms of u, so u would be equal to g of a and g of b. That's it. So this rule says that when using a substitution in a definite integral, we must put everything in terms of the new variable u, even the limits, okay? The lower and the upper limits. Not only x and dx, but also the limits of integration. So we find the value of u that corresponds to x equals a and x equals b. Let us try to solve this integral. So first I think of u. Well, I'll take u, the inside function, which is 3 minus 5x. Now let me find du. Du would be the derivative of this, which is negative 5 dx. Something else now I need to find. If x is 1, what would be u? Well, u would be 3 minus 5 times 1, which is 3 minus 5, which is negative 2. And if x is 2, the upper limit, what would be the value of u? This is u. So to find u when x is 2, you replace x by 2. So 3 minus 5 times 2. 3 minus 10 is negative 7. Now, I have integral 1 to 2. I have 3 minus 5x to the power 2 in the denominator. This would be u to the power 2. But I have in the numerator dx. Well, dx is not enough. I need negative 5 dx. So I will multiply by negative 5 and I will divide by negative 5 outside. So now this integral would be equal to, I'm changing everything to u. So 1 would be negative 2. 2 would be negative 7. Negative 5 dx would be du. 3 minus 5x would be u, and this would be the new integral, which is an easy integral. So I have negative 1 over 5. What is the integral of 1 over u square? You can write this u to the power negative 2, and the integral would be u to the power negative 1 over negative 1 from negative 2 to negative 7. Negative 1 over 5 times negative 1 is 1 over 5, and I will write this as 1 over u from negative 2 to negative 7. So it would be 1 over 5. I replace u by negative 7. So it's 1 over negative 7 minus, I replace u with negative 2, and I can find the answer using the calculator. So negative 1 over 7 plus half, or 1 over 2, over 5. So the answer is 1 over 14. This is the integral of this function. Of course, you can check your answer now. You can put this in the calculator and check that the answer is 1 over 14. One more example. Well, let us choose u here. What would be u? Inside ln, I have x. So choosing u as x changes nothing. If I take u in this example, ln x, this function, ln x, what would happen? Then du would be equal to the derivative of ln x, which is 1 over x dx. Well, look to this integral. Let us change the limits first. If x is 1, u would be ln 1, which is 0. If x is e, u would be ln e, which is 1. Look to this integral. I can write it 1e, and I can write it ln x, okay, times 1 over x dx. Ln x over x can be written as 1 over x times ln x. Why I wrote it like this? To let you see now that ln x is u, and 1 over x dx is du, and I'm changing to u. So if x is 1, u is 0, and if x is e, u is 1. And you find this integral. The integral of u is u squared over 2 from 0 to 1. So if you replace u by 1, you will have half minus 0, it would be 0. So the answer is half. I hope you enjoyed substitution, and study hard and have a nice